Okay, so the first thing we're going to do is solve a problem like this. But when you solve a problem like this, you need to start by saying, wait a second, I've got denominators where the variable is, and so I have to be careful to make sure that my answer doesn't come out to be something that gives me a 0 in the denominator. So from the beginning, we know that x cannot equal 1 or -2, because that would give us zeros in the denominators. After that, then it's just a matter of clearing out the denominators and then solving the quadratic that's remaining. And so when we do that, we're going to multiply by x minus 1 times x plus 2. And so that'll cancel out the x minus 1, so that gives you 4x times x plus 2 minus x plus 3 times x plus x minus 1, because the x plus 2 cancels, and that'll equal this x minus 1 times x plus 2. We need to go through and simplify all this, so that is going to be 4x squared plus 8x minus this would give me, what, x squared plus 2x minus 3. And so that's going to give me minus x squared minus 2x plus 3. When I multiply this out, I get x squared plus x minus 2. I'm going to subtract x squared. And so 4x squared minus x squared minus x squared would give me 2x squared. 8x minus 2x is 6x. Minus x here gives you plus 5x. And then add 2 to both sides, and you get 5 equals 0. Now I need to go through and solve this equation. The way I solve this is going to be using the quadratic formula. Remember, the quadratic formula is x squared minus equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. And so that's going to give you negative 5 plus or minus a square root of 25 minus 4 times 2 times 5 all over 2 times 2, which gives me negative 5 plus or minus the square root of, well, this turns out to be negative 15 over 4, so my answer is no solution. There are no solutions because I end up with a negative, or no real solutions because I end up with a negative in the square root. And the second thing we're going to look at is if I've got an equation, ax squared plus bx plus c equals 0. What the quadratic equation or quadratic formula really is telling us is that the solutions to this equation are negative b plus or minus square root of b squared minus 4ac all over 2a, and negative b minus the square root of b squared minus 4ac all over 2a. And from this, we can actually then determine two important things. And that is, what is the sum of the roots? And what is the product of the roots? And these are can be some valuable tools. So let's just go ahead and calculate it for this problem. So the sum of the roots is going to be adding these together. Well, these are opposites of each other. So you get negative b plus square root of b squared minus 4ac plus negative b minus b square root of b squared minus 4ac. So that b squared minus 4ac cancels out. So I end up with negative 2a, or 2b, over 2a, which gives me a negative b over a. And so what are two pretty complicated looking solutions or roots, the sum of the two of them are not complicated at all and really just turn out to be an easy combination of those two coefficients, negative b over a. And then the product of the roots might seem really complicated, right? Let's go ahead and write this one out. Until we realize what's actually happening is the difference of squares. And if you notice here, we're going to have this times this, which gives you b squared, but the middle terms is going to be negative b times that, which gives you positive b times that thing, but this is going to give you that times negative b, which gives you negative b times that thing, which cancels out. And so that means we're going to have minus this thing squared, which is just going to be what's inside the radical, right? When you square a radical, it's just what's inside the radical. And then the denominator is 2a times 2a, which is going to give you 4a squared. Well, when I simplify this, notice what happens. B squared minus b squared goes away. You get a positive 4ac over 4a squared. One of the a's cancels out, the 4 cancels out, and the product of the roots turns out to just be c over a. And this is actually what we refer to as Vieta's formula. And we can generalize it even further when we say A equals 1. And so Vieta's formula says for the quadratic equation x squared plus bx plus c equals 0, the sum of the roots, well, notice this is exactly the same problem I did here, except that I had a equal 1 instead of a. And so if the sum of the roots was negative b over a, for our actual formula, we're going to say the sum of the roots is negative b, and the product of the roots is c. So to use this formula, we might ask a question like this. What are the sum and product of the solutions to 3x squared minus 6x minus 24 equals 0? Well, when you use Vietas, since we let the coefficient here be 1, we just need to divide through by 3 to begin. So we divide everything by 3, and we get x squared minus 2x minus 8 equals 0. So the sum of the roots is equal to b, or negative b, so opposite of negative 2, which is positive 2, and the product of the roots equals negative 8. Well, this is actually a problem we know how to solve very easily. We could have factored this, right? And you get x minus 4 times x plus 2 equals 0. And so x equals 4 comma negative 2. 4 plus negative 2 equals the sum. 4 times negative 2 equals negative 8. And that's actually another way to prove Vietas. Rather than using the quadratic formula like we did up here, you could also say, let the roots be R1 and R2. And so you'd say x minus R1 times x minus R2 equals 0 would be the factorization of this quadratic. And when you multiply this out, you get x squared minus, well, it's going to be negative R1x, negative R2x. So we can combine those together. And from that, and then we multiply negative R1 times negative R2 to get R1 times R2. So we can see that this is the product of the roots, that C term. This is the sum of the roots, but it's got to be the opposite, because when we talk about roots, it's always x minus that. And so that's where that negative and opposite comes into play on these. The classic example of a problem that involves Vietas is to do this. If R1, or if A and B, actually, let's say if M and N are the roots of x squared plus 4x minus 9 equals 0, what is the sum of the reciprocals of the roots? Or what is the sum and the reciprocals of m and n? So what we're trying to find is 1 over m plus 1 over n. Well, if we did the quadratic formula on this, we'd get something that was relatively ugly. And so then taking the reciprocal, that would get even uglier, because you're taking that binomial that's usually on the top and putting it in the denominator. So instead, we simplify this first, which the common denominator would be mn, and it just turns out that that adds together to give you m plus n over mn, right? This becomes n over mn. This becomes m over nm. So we can add those together to get n plus m over nn. Well, this is the sum of the two roots. This is the product of the two roots. Well, from Vietas, we know that the sum of the two roots is the opposite of the b coefficient. And so the opposite of 4 is negative 4. And then we know that the product of the roots is the C coefficient, which is -9. And so the sum of the reciprocals of the roots m and n is 4/9. So it's a nice application of how to use the Vietas formula, which tells you very quickly what the sum and the product of the roots of a quadratic are.